Okay, I want to talk about a problem that we did in class today, and that is problem number 6 from the 2009 BC test. And in this problem, we're given the fact that the Maclaurin series for e to the x is equal to 1 plus x squared plus x to the third over 6. But then we're given a continuous function f that is defined by f of x is equal to e to the x minus 1 quantity squared minus 1 over x minus 1 quantity squared for x not equal to 1. Obviously at x equals 1 the function is not defined, but that would be a hole at x equals 1, and to fill in that hole we would just set f of 1 equal to 1. And the function f has derivatives of all orders at x equals 1. And the first thing we're asked to do is to write the first four non-zero terms and the general term of the Taylor series for e to the x minus 1 quantity squared about x equals 1. Well, this is the way I would go about doing this. We know that e to the x is equal to 1 plus x squared over 2 factorial plus x to the third over 3 factorial, etc. Now it's given in this problem, but it is assumed that you would either be able to come up with that Maclaurin series or to memorize it. Since we're trying to do the Taylor series for e to the x minus 1 quantity squared, we might next want to do e to the x squared. And in this case, we're just going to replace wherever we see an x, we're going to replace with x squared. And when we do that, we're going to end up with 1 plus x squared plus x to the fourth over 2 factorial plus x to the sixth over 3 factorial. Again, assuming we start with the zeroth term, we have 0. The zero term is 1, the first term is x to the second term is x to the fourth over 2 factorial, and x to the sixth over 3 factorial. So you can see that that's just x to the 2n over n factorial. Alright, the next thing that we're going to do is we're going to shift this over to the right, and we're going to find out what e to the x minus 1 squared is. And for that, wherever we see x now, we're just going to replace it with x minus 1. And so that gives us 1 plus x minus 1 quantity squared plus x minus 1 to the fourth over 2 factorial plus x minus 1 quantity to the sixth over 3 factorial, etc. And so that is the answer for A. So we'll take a second to take that in. And the next thing we want to do in part B is to use the Taylor series that we found in part A to write the first four non-zero terms and the general term for the Taylor series for f about x equals 1. And remember that f is this e to the x minus 1 quantity squared minus 1 over x minus 1 squared. Well, the first thing we're going to do is work on the numerator, and all we need to do to complete the numerator is to subtract 1. And that starts off being just the same as we had above, only we're going to now subtract 1 from that. And when we do that, we're left with everything that we had above, except that the two 1's will zero each other out. And we're almost there. Now the only thing that we still need to do is to divide the whole expression by x minus 1 quantity squared. And so for that, we're just going to divide each term by x minus 1 squared. And from there we can simplify. And so we can find that we have the first three terms there. The fourth term would just follow that pattern. It would be x minus 1 to the sixth over 4 factorial. And if we start with the zeroth term, we can see that the denominator is always n plus 1 factorial, and the numerator is always 2n factorial, 2n for the exponent. And so that is our answer for part B. And we'll continue with part C and D in the next video.